Physical and chemical changes. Changes. The world around us is forever changing. A change could be spread over a day, to months or years. When you get up in the morning, it is quite pleasant. After few hours, the temperature rises and you don't want to venture out. Again, after few more hours, the heat starts ebbing away, but light starts fading, and then comes nightfall. You see, all these changes occur in a span of just 24 hours. Similarly, with the passage of each month, you find changes in your surroundings. Different flowers bloom at different times of the year. Different fruits are available in different seasons, and so on. Change is an integral part of the nature, be it a physical phenomenon or a biological phenomenon. Let us classify changes into different categories and learn about them. Changes can be categorized as follows. Different types of changes. Natural changes. A change that occurs naturally, like rising of sun, change of season, formation of clouds. Man-made changes. A change that occurs due to the action of human activities, like construction of bridge, dams, etc. Desirable changes. A useful change which is good for us, like ripening of fruits and formation of curd from milk. Undesirable changes. A harmful change which is not good for us, like rotting of fruits and spoilage of food. Reversible changes. A change that can be reversed, like ice melts and changes to water. Water again can turn to ice. Irreversible changes. A change that cannot be reversed, like milk can change to curd, but curd cannot turn to milk. Slow changes. And takes long time, like pupa to butterfly, seed to plant. Fast changes. A change that takes place fast, like baking of cake, burning of paper, bursting of firecrackers. Periodic changes. A change which occurs after a regular interval, like change of season, day to night. Non-periodic changes. A change which is not repeated after a regular interval, like volcanic eruptions, thunder, and lightning. Physical and chemical changes. All changes that we discussed earlier are not as important as this category because chemistry, which deals with composition of materials, has a direct correlation with these changes. Physical change. It is a change which is not accompanied with any change in the chemical composition of a substance, but affects only the physical properties of a substance. All physical phenomena occurring in nature fall in this category. Physical properties are those properties which can be perceived by our senses, like color, odor, etc. Chemical change. A change which alters the specific properties of a substance by bringing about a change in its molecular composition followed by a change in its state is called chemical change. New substance is formed by chemical change. Activity. Take some sugar crystals in a china dish. Heat the dish. You will see that sugar first turns brown and on strong heating turns black. Taste it. It does not taste sweet, but has the taste of burnt food. Why? When you heated sugar, it decomposed, forming carbon and water. What you saw in china dish later was black carbon and not sugar. Since carbon has totally different properties as compared to sugar, it did not taste sweet like sugar. Differentiating between physical and chemical change. If you look around yourself, you will find many examples of physical and chemical changes. Try to classify them and also find reasons before declaring them to be a physical or a chemical change. Physical changes, chemical changes. A physical change can be reversed. A chemical change cannot be reversed. In physical change, the chemical composition of a substance remains same. In chemical change, the chemical composition of a substance changes, like melting of wax, like burning of candle wick. 1. Physical change is generally reversible. Since a physical change does not involve change in molecular composition, in most of the cases it is reversible. For example, glowing of a bulb is a reversible physical change. Similarly, change of color of zinc oxide from white to yellow on heating and again back to white on cooling is also a physical change. Melting of ice, sublimation of iodine are also examples of physical change. Let us understand sublimation through an activity. Activity. Take some iodine crystals which are black and shiny in a test tube and then heat the test tube gently over a Bunsen burner. You will see that the test tube is filled with violet vapors, some of which leave the test tube also. When there is nothing left in the test tube, stop heating and examine the test tube. You will find that there is a deposition of black shiny substance near the mouth of the test tube. When you heat the test tube, iodine crystals don't melt like other solids, but directly change into vapors. This phenomenon is called sublimation. When vapors cool, they again get converted into shiny crystals of iodine which you saw near the mouth of test tube. Although most of the physical changes are reversible, but there are numerous exceptions to this, like breaking of glass, bursting of water pipes, melting of ice cream, etc. 2. Chemical change is irreversible by any physical means. A. When milk changes into curd, a new chemical substance is formed, which cannot be converted back into milk. B. When food is digested in our body, numerous enzymes take part in the process, and change is irreversible. C. Growth of a plant. When a plant grows, new cells are formed. Even if you cut the plant which has grown into a tree, you would not be able to reverse the change. 3. No energy change takes place during physical change. When you heat a solid and it melts, the energy supplied by you during heating is getting converted to another form of energy and is stored in the molecules of liquid. When liquid will solidify, it will release the same amount of energy which it had absorbed during melting. Hence, overall, no energy change has taken place. 4. Chemical change is generally accompanied with either liberation or absorption of heat. Activity. Take a piece of quicklime in a test tube and add water to it. You will hear a hissing sound and the test tube will become warm. The chemical reaction taking place is called exothermic. Exo, evolving. Thermic, heat. Take a small quantity of ammonium chloride in a test tube and add water to it. Touch the walls of the test tube. They turn cold. In the first case, heat is evolved during chemical reaction. Such a chemical reaction is called exothermic reaction. In the second case, heat is absorbed during chemical reaction. Such a reaction is called endothermic reaction. Some common examples of exothermic reactions are burning, glowing of an electric bulb, etc. Melting, evaporation, etc. are some common examples of endothermic reactions. 5. No new substance is formed during a physical change. Since no change in chemical composition takes place during a physical change, therefore, no new substance is formed. Examples: A. Dissolving of salt in water. Taste of water changes, but if you evaporate the solution to dryness over a sand bath, salt is obtained as a residue. Hence, no change in the composition occurred. B. Tearing of paper. A torn paper cannot be restored, but bits and pieces of paper are not a new substance and resemble the original paper. 6. Chemical change is accompanied with a change in weight. Activity: take some unpolished iron nails in a china dish, weigh them and cover them with a moist cotton. After few days, you will find that the nails are covered with a reddish-brown kind of powder. Remove the cotton and weigh them again. You will find that their weight has increased. Why? When you left iron nails with moist cotton exposed to air, the nails combined with the oxygen and the moisture present in air, forming a compound called hydrated ferric oxide. The process that took place is called rusting, and gain in weight is due to addition of the weights of oxygen and moisture to that of iron. Classification as physical and chemical change. Change of state. If you heat the wax in a test tube, it melts, and when you stop heating, it again solidifies. Hence, heat is the external agent, and the change is reversible and a physical change. Change of energy. Burning of paper, cloth, or wood, or other fuels is a chemical change, where the paper or cloth or fuel that gets burnt cannot be reversed to its original form. However, energy is released on burning mainly as heat and light. This is also called exothermic change. In terms of energy, most of the examples of change of state can be called endothermic changes. When the energy is absorbed in the form of heat, it is called endothermic change. Like cooking of food, melting ice, etc. Characteristic of physical and chemical change. Physical change characteristics. In general, physical change is reversible and temporary. Chemical composition remains same throughout the change. During change, no new substance is formed. A physical change may be the reason of changes in color, geometry, and state of the substance. Mass remains unaltered, Chemical change characteristics. A chemical change is usually an irreversible, permanent change. In some cases, chemical changes are reversible. During a chemical change, new substances are formed. Newly formed substances differ in chemical composition and characteristic properties of original substances. Exchange of energy occurs during a chemical change in form of heat or light. During chemical change, mass of substance is altered. Physical changes. Physical changes are most common phenomenon observed in nature. A lot of them occur around us, and we experience them in our daily life. Some of them are described below. Freezing. Freezing is the solidification of a liquid which takes place on lowering its temperature. The temperature at which a liquid solidifies is called its freezing point. Every liquid has its specific freezing point. Freezing takes place on constant temperature. For example, freezing point of water is 0 degrees Celsius. It can be converted back to liquid by heating. Melting. Melting, also known as fusion, is liquefaction process in which a solid converted to liquid after receiving heat. The temperature at which a solid melts is called its melting point. Melting point of ice is 0 degrees Celsius. It can be converted back to solid by cooling. Vaporization. Vaporization is the process of conversion of a liquid into gaseous form. It occurs in two manners: boiling and evaporation. In boiling, vaporization takes place by heating at a constant temperature, called boiling temperature, while in evaporation, vaporization occurs below boiling point through continuous heating. For example, formation of steam from boiling water is an example of boiling, while formation of water vapor from seawater through continuous heating is an example of evaporation. A gas can be converted back into liquid form by lowering its temperature. Condensation. Condensation is the process in which a vapor, gas, is converted back into its liquid form by lowering the temperature. During the whole process, temperature remains constant. Effect of condensation can be reversed by reversing its temperature. For example, water vapor can be converted back into liquid through condensation. Sublimation. Sublimation is the process of conversion of a solid directly into gaseous state. In sublimation, solids does not pass through liquid state. The process can be reversed by lowering the temperature. Naphthalene balls are used to protect woolen clothes from insects. The reason behind keeping them covered with cloth is because they sublimate at room temperature. Dissolution. Process of dissolving a solid into liquid is called dissolution. It forms a solution. The solid can be obtained back by evaporation from solution. Solution of sugar and water, salt and water are examples of dissolution. Chemical changes. Chemical changes are completely different from physical changes in many manners. A chemical change involves change of mass, energy transfer, new substance formation, etc. Some of the chemical changes are described below. Rusting. Rusting is a process of continuous disintegration of iron with respect to time. This happens due to formation of iron oxide layer, which weakens the strength of iron metal. In other metals, rusting is termed as corrosion. Most common example of corrosion is formation of oxide layer over aluminium. Due to its highly reactive nature, aluminium instantly reacts with oxygen molecules present in air when it is exposed in free atmosphere. Burning. Burning is a chemical process in which a fuel is burned to produce heat energy, which further utilized in various manners to do useful mechanical work. Burning of coal, gasoline, LPG, CNG, etc. produces heat energy, which further gets converted into useful mechanical work. Curdling. Through curdling process, a liquid is converted to semi-solid substance. Formation of curd from milk is an example of curdling. It is an irreversible process. Similarly, production of butter, cheese is done through curdling.